Again, welcome to Unit 1, Part 2 lectures. And this is the continuation of Unit 1, Part 1 lectures, which focus on real numbers. So here we continue with a set of real numbers. Our main objective here is how to graph intervals on the number line. Previously, we learned how to graph numbers on a number line. We're also going to learn how to define absolute value and how to find a distance on a number line. So graph intervals on a number line. There are some few operators that we have to know, and we call these operators inequality symbols. For example, not equal. Example given here, 5 is not equal to 8. And also the symbol for less than, which is a left arrow. A good example is 12 is less than 20. We also have the greater than symbol, right arrow. 15 is greater than 9. Or 25 is less than or equal to 25. So left arrow with a line under is less than or equal. Right arrow with an underline means greater than or equal. Then a carry brace, kind of a carry equality, we use the term approximate. So for example, square root of 2 is approximately 1414, which means we still have a lot of decimal values continue, but we just approximate it to 3 decimal places. So with this symbol in hand, we can easily graph an intervals on a number line. So for example, here we have s is less than or equal to 5. Since we are going to include 5, we use the straight line with less than, so it will go to the left side. If it's greater than, it will go to the right. As we said earlier, plotting the values on a number line. When we go to the left side of the line, the value is decreasing. That's why it's negative mostly. To the right, the value is increasing. Here, the symbol said we should have x that is less than or equal to 5. So I'll make a straight line, then to the left, less than. Now, this example said greater than -2. So we can see it's not a straight line. A straight line means including 5. So less than or equal to 5, including 5. But here they told us greater than -2, which means excluding -2 is greater. If it's greater than or equal, then we have a straight line, which means excluding -2. Now, since it's greater than, the arrow will face right. We know increasing values is to the right of the line. When the value is decreasing, we go to the left direction. So those are the 2 examples of graphing on a number line. When we have equality, then we have a straight line. Since this is less than, we go to the left, less than direction. Greater than is to the right, but this greater than excluding -2, because they say s is greater than -2, which means -2 is not included. Now here we have s is less than 12 or greater than 5. So which means I have to go somewhere between 5 to 12. But excluding the 5 and the 12 itself. So we have a parenthesis instead of straight line. So from 5 to 12. So the graph shown below also a portion of a number line called intervals, these 2 intervals. So if I have x is less than 4 or greater than -2, then it will be from -2 to 4. Now if I have 1 to infinity, it means I'll start from 1, increase to infinity. Also, we have a compound inequality. An example would be, the reason why it's called compound, instead of the previous example, we had to have s is greater than 4, s is less than 4, or s is greater than or equal to 4, etc. But we can also have a compound equality. Here we say s is less than 4, but it's greater than negative 2. We can either separate it. This means s is greater than negative 2 and s is less than 4. Or we can join the two together. So this expression represents the intersection of two intervals. In the interval notation, the expression can be written as following: from negative 2 to infinity, and from a negative infinity to 4. And the next one, we have s is less than 5 or greater than negative 3. So we have negative 3 and 5 and draw a straight line. So if an interval extends forever in one direction, again, it's called an unbounded interval. And these are some couple of unbounded intervals. So interval from a to infinity, if s is greater than a. So we go from a to infinity. And the next one we have s is greater than 2. So from 2 is greater, so excluding the 2. It's increasing also. Here we say x is greater than or equal, so it's a straight line. S is greater than or equal, so it will be straight line on the 2. And both will go to the right direction, since it's greater. Less than will go to the left direction, so we have s is less than 8, so from a to the left. Or s is less than 2. And also s is less than or equal to a. Less than or equal to 2. And negative infinity to positive infinity means everything. We also have the open interval. So here we say a bounded interval with no endpoints is called an open interval. Then with one endpoint is called a half open interval. With two endpoints is called a closed interval. So we can see the first example here. It's open interval. And here also the same thing, negative 2 to 3. So it's open interval. The same thing. And the same open interval. So the expression x is less than negative 2 or s is greater than or equal to 3. Read as following. Read as s is less than negative 2 or s is greater than or equal to 3. We can represent the union of two intervals. So in interval notation, it is written as negative infinity to negative 2 and then 3 to positive infinity. So next we go to defining absolute value. We know absolute value means our answer is always positive. So if I have negative 4 absolute always have to be in a vertical line. So negative 4 absolute will give me 4, and the answer will be 4. This one says if s is a real number, then absolute s equal to x, or absolute s equal to negative s. So write each number without using absolute value symbols. So we know 3 will give me 3, negative 4 will give me positive 4, 0 is 0, negative 7 will give me positive 7 times negative, so you get negative 7. And the last section is finding the distance on a normal line. Normally we find the difference. So if I have A and B are the coordinate of 2 points on a normal line, the distance D between the points is given by the following formula. You can say D equal to B minus A. So this is example. Find the distance on a normal line between the endpoints with a given coordinate 3 and 5. It will be 5 minus 3, which will give us 2. 3 minus 2 will give me 5. Then minus 5 will give me 4. So again, thank you for watching this video. This video will be the conclusion of real numbers, and we again went through some few rules here. So again, wish everybody the best.